Hi. So in this lesson we're going to talk about whole numbers. So the first thing I'm going to talk about is the place value and the number base. So let's say we have a number 121 or 1021. The place value would be the location of the number in the whole number. So the place value of 2 would be in the tens location, for example. The place value of 1 is in the ones location. So what I mean by this is in the ones position, this is in the tens position, 0 would be in the hundreds position, and 1 would be in the 1000s position. So if we broke this up, we could rewrite this as, to get this number we can do 1 times 1 plus 2 times 10 plus 0 times 100 plus 1 times 1000. And you see here 1 times 1 is 1 plus 2 times 10 is 20. 0 times 100 is 0. And 1 times 1000 is 1000. So, if you add 1 and 20, you get 21. Then we can ignore the 0 and just go ahead and add 1000. And that will give us 1021. So that's how place values work. So the next thing I'm going to talk about is number bases. So usually we use base 10 of numbers. So basically what that's saying is there's 10 different numbers that we use. The 10 numbers used in base 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the 10 different numbers we use. There's other bases that you can use as well though. For example, programmers might use base 2 numbers, or sometimes referred to as binary. Since it's base 2, it uses 2 numbers, and those 2 numbers would just be 0 and 1. Another common number base is base 16. So, I mean, that one's kind of weird, like, how do you get more numbers than 9, because these are the only number digits we have. So in base 16, what happens? They have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you can't do 10 because that would be using 1 and 0. So what they do instead of 10 is they just do A, and then they do B, C, D, E. So this would be 10, 11, 12, 13, 14, 15. And if you account for the 0, that's 16 numbers, so that's base 16. And that's basically all I'm going to show you for number bases, so that's it. Hi, so in this lesson we're going to talk about integers, and we're going to cover first adding, subtracting, multiplying, and dividing integers. So let's start with adding. Let's say you have 2 integers, 1 plus 4. if you want to break this down and simplify it, you can break this into one object. Let's do one circle and 4 circles for 4. And then you can simply count the number of circles. 1, 2, 3, 4, 5. So that means you have 5 circles, and the answer is 5. So that's how adding works. Obviously, it takes longer if you want to break it down that much. So basically, the name of the game with adding is lots of memorization. That helps a lot. Highly recommend it. Learning all your adding tables. I mean, counting the numbers on your fingers is a good strategy as well. So next I'm going to talk about subtracting. Let's do 8 minus 2. So once again, if we break this up into circles, we have 8 circles, and then minus 2. So if we take away 2 of these circles of the 8, then that would take away those, and you see we have 6 circles left. So the answer is 6. So next we're going to talk about multiplying. Let's do 2 times 3. So basically what this is saying is if we have 2 circles times 3 circles, we're going to make 3 groups of 2. So the answer is 1, 2, that's the first group, 1, 2, that's the second group, 1, 2, that's the third group. So the answer is 6. And next we're going to talk about dividing. So let's do 6 divided by 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So what this is saying is, how many times can we take 3 circles out of this? If you want to visualize it like this, you can draw a line through here, and you just split the 6 circles up into 2 groups of 3. So that means we can take 3 out of 6 twice. So the answer here would be 2. And yeah, with multiplying, subtracting, adding, division, like it's just a bunch of memorization. Like that's super important. It'll be super helpful once you get to higher level math. It's really important to get the basics down. So the next thing we're going to talk about is the order of operations. Order of operations is a very important concept. It's what gives a lot of people a lot of different problems. So basically what that's saying is you have to know what order to do everything in. So let's say you have this equation, 6 times 2 plus 3 squared minus 5, and let's say that's 5 squared times 2 equals. So we got 5 squared times 2. Which do we do first? We can square it. Let's start with this one. We can square it and then multiply it, or we can multiply and then square it. So if we multiplied and then squared it, we'd get 10 squared. And I'll ignore this side for now and then work on that later. 10 squared would be 100. But let's try it the other way. Let's see if it gets us 100, because if it did, then we definitely got it right. So 5 squared is 25. Then times 2. that's going to be 50. So, as you can see, it matters what order we do things in. Should we square it first, or should we multiply first? And that's just one example. But basically, the rule you need to remember is you need to do parentheses, exponents, multiplication, division, addition, and subtraction. And that's the order you need to do it in. So here's the acronym that a lot of people like to remember for that. Parentheses, exponents, multiplication, division, addition, and subtraction. So let's go back to this problem and then follow that rule. Okay, first start with parentheses. So what that means, here's our parentheses. We first start by multiplying these in, 6 into these two. So we got 6 times 2 plus 6 times 3 squared. And we cannot multiply 6 by the 3 yet because the exponent's there. And once we do the e part of the rule, then we can do the n part of the rule where we multiply them together. So the exponent, I'll go ahead and write this out, minus 5 squared times 2. Exponents would be the 3 squared and 5 squared. So we'll get 6 times 2 plus 6 times 3 squared, which is 9, minus 5 squared, 25 times 2. Okay, so next step is m, multiplication. 6 times 2, 12, plus 6 times 9, it's going to be 54, minus 25 times 2, so that's 50. Okay, and now we can go ahead and do division. In this problem there is no division, so we can move on to addition. 12 plus 54. That will be 66, and then minus 50. And the last step is subtraction. So 66 minus 50 is going to get us 16. And that is how you do the order operations. You just got to remember PEMDAS, and that'll help you to remember everything. Alright, so now we're going to talk about fractions and mixed numbers. So first we're going to talk about multiplying and dividing fractions, which are sometimes referred to as rational numbers as well. So let's say we have 3 halves times 4 fifths. How you do this is you multiply the top together and you multiply the bottom together. So 3 times 4, that's 12. 2 times 5, that's 10. And it's as simple as that. But you can also simplify it sometimes. But we will so if you see here, you can take a 2 out of the 12 and a 2 out of the 10. You can rewrite this as 6 times 2 over 5 times 2. The 2's will cancel out, and that leaves you with 6 fifths. You can also rewrite this as 1 and 1 fifth if you would like. Alright, so next is dividing fractions. Let's do the same problem. 3 halves divided by, instead of multiplying, divided by 4 fifths. So when you divide, it's the same thing as multiplying by the reciprocal. So 3 halves times 5 fourths. So you can rewrite it like that. When it's dividing, you just flip this one over. Alright, so we got 3 times 5, 15, 2 times 4, 8. And do these have any common factors? No, they do not. So if you wanted to write it as a mixed number, you can write it as 1 7/8 if you would like. Alright, so next is adding and subtracting fractions. Let's say we have 2/5 plus 1/5. When you're adding and subtracting fractions, you might be tempted to add the bottom together, but in this case you cannot do that. You just add the top together. So 2 plus 1, that's 3/5. And that's our answer right there. You can also, once again, look to see if you can simplify it. Both 3 and 5 are prime numbers, so in this case you cannot do that. Subtracting fractions, let's say we have 1/3 minus 1/6. Okay, so another rule with adding and subtracting, when you add or subtract, they have to have the same denominator, so the same number on the bottom. So what we can do with this to get them at the same denominator is multiply 1/3 by 1. And I'm going to write 1 as 2/2, because 2 divided by 2 is the same thing as 1. Times 1/3 equals 2/6, so we got 2/6 minus 1/6, and that will give us 1/6. So that's how you subtract. And another important thing to remember is whenever you're doing all these operations, you're still going to follow PEMDAS. Yeah, basically gotta always remember the order of operations. It's going to be really important. Alright, so next we're going to talk about decimals. Adding, subtracting, multiplying decimals, dividing decimals. So let's say we have 2.4 plus 3.1. So a new method of adding, we can just stack them on top of each other, 2.4 plus 3.1. In this method, you just add the 1 and 4, so that gives you 5. You add the decimal, you carry it down, and then you add the 2 and 3, so that gives you 5.5. So that is how you add decimals. Now let's do subtracting. 2.4 minus 3.1, 2.4 minus 3.1. Alright, 4 minus 1, that is 3. And 2 minus 3, that is going to be -1. So our answer is actually going to be -1.3. Alright, so multiplying fractions. Let's do 2.4 times 3.1. 2.4 times 3.1. 1 times, start with 1 times 4. That's 4. 1 times 2, that's 2. And then 3 times 4. So since this is in the 1's position, you start over. 3 times 4 is 12. We just put the 2 there and carry the 12 up here. 3 times 2 is 6 plus 1, so that's 7. And then you gotta add these two together. 4, 4, 7. And when multiplying decimals, you add 1 decimal for every decimal space there. So in this one, there's 1 decimal space, and this one, there's 1 over, 1 over. So in this case, we go 2 over, since there's 2 decimals, and our answer is 7.44. Alright, dividing. Let's do 6 divided by 0.5. So, in this case, I would actually like to write this as a fraction. So 6 divided by 1/2, because 0.5 is 1/2. So if you remember, when dividing fractions, you can just multiply reciprocal, so we'll get 6 times 2 over 1, and that gives us 12 for our answer. Alright, so now I will continue on with decimals and talk about fractions and decimals, how they relate. So that kind of came into our last problem. So let's convert a decimal to a fraction, 0.1. This is in the 1/10ths place. So as a fraction, that would be written as 1 over 10. How about 0.01? That's in the 100ths place, so that would be 1 over 100. How about 0.001? This is in the 1000ths place, so that would be 1 over 1000. And so on. You'll just keep on adding more zeros the farther it is away from the decimal. And so, let's say, I'll show you how I converted the 0.5 to a fraction now. 0.5 is just like this was 1/10. Since this is 5, this is 5/10. And now you can rewrite this to 5 over 2 times 5, since 2 times 5 is 10. Now that cancels out, and you're left with 1/2. So that is how you convert between decimals and fractions. And now we're going to talk about square roots as well. So you got the square root of 4. You can break this up into 2 times 2, and basically whenever you have 2 numbers inside of the square root, you can take it out side of the square root. So you got 2 times square root of 1, since, you can always rewrite it with the assumed 1. And the square root of 1 is 1, so that's just 2. So the square root of 4 is 2. But sometimes you got the square root of numbers that are not perfect square roots, like this, like 4. So the square root of 2, that's going to be some decimal number. And let me put it in my calculator to see exactly what it is. Square root of 2. 1.414. So yeah. In some cases, you just got to keep in mind with square roots, it's not always going to be a perfect square. Might come up to a decimal, pretty ugly number, so just keep that in mind. Alright, so now we're going to talk about ratios, proportions, and percentage. A ratio is basically just 2 numbers over each other, 1 over 2, that's a ratio. If you're reading it as a ratio, how you would read it is 1 out of 2. So let's say you want to know the ratio of men to women, so I think it's actually written like that with the colon a lot of times. So if 1 was for men and 2 was for women, this would be saying for every 1 man there's 2 women. So that's how ratios work. And proportions. Proportions is basically like how much of something there is. So there's lots of different ways you can write proportions, like 1 out of 2. It's the same thing, like for every, or you could show it as like 50%. 50% of the population is men, or something like that. So we're going to talk about percents, decimals, and fractions. So you got this 50% right here, and if, let's say you wanted to convert it to a decimal, the way you convert a percent to a decimal is you take the number 50, divide by 100, and when you're dividing by 100, that just means you move the decimal right here over 2, so 1, 2, decimal goes there. That means your answer is 0.5. This is 50% written as a decimal. If you want to convert back, 0.5 times 100. To convert decimals to percents, you just multiply by 100. So that's going to get you 50 because the decimal goes over twice. Boom, you got 50. And yeah, so I'll just give you an example problem. Let's say you have 10 men and 5 women. So this will help you with your problem solving. The question is, what is the ratio of men to women? So you can write 10 to 5, like that's easy, but it can be simplified, so you want to simplify it. You can rewrite it as the 10 as 10 times, sorry, not 10, 5 times 2 to 5, and these 5s can cancel out, and that will leave you with 2 to 1. So the ratio of men to women is, for every 2 men, there's 1 woman. I can also ask you, what percentage of the people is men? So the equation for a percent is sample divided by total times 100. So the sample, you're looking at the men, so that'd be 10 divided by the total. The total would be the total number of people, so you'd have to do 10 plus 5. So that equals 10 over 15, and then times 100. So let's go ahead and put that in on the calculator. 10 divided by 15 times 100. So that looks like it's 66.7%. There's lots of different ways you can use this, like if you want to know what percent of the people in your school are women, you can just count the total number of men and women, and then you plug it into that formula that I just gave you. But you can also do it the other way around. Let's say you are told that 66.7% of the people in your school are women. If you're given that information, can you tell me, if there are 1,000 people in your school, how many women out of the 1,000, sorry, how many people out of the 1,000 are women? Okay, so we got our equation here. Sample divided by the total, actually I'm just going to ignore the equation. Tell you the really simple way. What you got to do is convert this to a decimal. So if you remember how to do that, 66.7 divided by 100, just move this over 2 places because you're dividing by 100, 0.667, oh, it's a decimal. And now to find the number, you can just do 0.667 times 1,000, and that will give you the number of women in the school. So if you're multiplying by 1,000, you'll actually just move the decimal over 3 places, and that'll give 667 women in the school. So that's kind of an application of how you can use that stuff and estimate things with percentage Let's also talk about interest while we're on the topic of percent. So you'll sometimes hear when talking about stock market or investing that something pays you 2% interest. Maybe your bank pays you 2% interest, or your credit card pays you that. So what this means is, if your bank pays you 2% interest and you have $1,000 in your bank, to calculate how much your bank is going to be paying you for having your $1,000 in your bank, you can just do 1,000 times 2 divided by 100, because you got to convert it to a decimal, so you divide by 100, and you can just cancel those zeros out. So you got 1,000 times 2, that'll give you 20 bucks. So I mean, that's pretty good. It's probably an annual interest rate. It's hard to find banks that'll pay you that much. But yeah, so that's how you can calculate how much the interest will pay you. And that will be it for ratios and percentages and stuff. Alright, so now we're going to talk about graphs and statistics. So basically to show you how to read a graph, I got this simple graph. Each tick represents one number. So this is 1, that's 2, that's 3, that's 4. So if you're at this point, you're at 3. And this is the x-axis. You also have the y-axis right here, so this is 1 on the y-axis, 2, 3, 4. So what this graph represents is, on the x-axis, the number of items sold, on the y-axis, the revenue. So basically, if you're at this point 1, that means you sold 1 item, and 2, that's 2 items, 3 items. And this line shows you the actual data. So let's take this point on the line. Can you tell me how much revenue you have for that point on the line and how many items are sold? So if you just trace over to the y-axis and down to the x-axis, you'll see you have $2 in revenue, because the units are dollars, and with 2 items sold. So every item selling for $1, we'll take it. So yeah, that's basically how you read graphs. And sometimes they'll be written in a table. So revenue, items, you'll have a column for both. If the revenue is 0, the items sold are going to be 0. Revenues 1, item sold is 1, 2, item sold is 2, 3, item sold is 3. So basically the numbers just correspond to each other like that. And that's how you're going to be reading tables, and you'll see a lot of those throughout your math classes, as well as graphs. And we're also going to talk about the mean, median, and mode, because those are really important statistic concepts. So the mean is the average. It's another word for average. I spelled that wrong, but I'm a math major, so we'll take it. So let's say you have the numbers 1, 3, 5. And I ask you, let's add another number, 6. And I ask you, what is the average of these 4 numbers? To find the average, you gotta add them all up. 1 plus 3 plus 5 plus 6. And then you divide by the total number of number zeros. So let's count. 1, 2, 3, 4. There's 4 numbers, so we divide by 4. So 1 plus 3 is 4, plus 5 is 9. So 9 plus 6 over 4. So that's going to equal 9 plus 6 is 15 over 4. And that's going to be like 3.75 or something like that. So this is our mean right there. Now we're going to talk about the median. So let's take these three numbers. The median is a number in the middle. So you start from the outside, move one over, and there's an even amount of numbers, so both of these numbers are in the middle. So in that case, we gotta add them up. 3 plus 5 divided by 2. 8 divided by 2. That's our median, which equals 4. So that's how you calculate median. I'll give you another example. 1, 3, 5, 6, 10. Alright, start at the 1, move over, start at 10, move over, start at 3, move over, start at 6, move over. So we see we converge on the 5. Since there's an odd number of numbers this time, we don't have to do this math thing, and our median is 5. So it's easier when there's an odd number of numbers. And next we're going to talk about the mode. The mode is the number that occurs the most. So let's say we have 1, 2, 4, 5, 8, 4. What is the mode? The mode is 4 because 4 occurs twice. None of the other numbers occur twice. So 4 occurs the most. If you see this one we did up here, all the numbers just occur once, so there is no mode in this one. So yeah, that's how the mode works. Alright, so now we're going to talk about algebra. So you'll see this a lot. Algebra equations usually look like 1 plus x equals 5 or something like that. X represents any number. It could be 100, it could be -5. We don't know what it is. So the point of an algebra equation is to figure out what x is. And there's some tricks you can do to that. So let's start with the equal sign. We got 1 equals 1. That's saying 1 is the same thing as 1. Yes, that's true. We can all see that. What if we add 2 to both sides? Plus 2, 3 equals 3. That's true, so that's good. That means, so what we figured out is we can add 2 to both sides and it'll still be true. What if we just add 2 to one side? You'll just get 3 equals 1. That's not true. So if you add anything to it, you have to do it to both sides. So that's honestly a big part of algebra. Like anything you do, you got the equal sign, you got to do the same thing to both sides. And you just always got to remember to do that. You can multiply, so 1 equals 1. If you multiply by 5 on both sides, that's fine. You'll just get 5 equals 5. You can add and subtract. 1 equals 1. Let's do minus 5. Minus 5 on this. So 1 minus 5 is -4. Equals -4. I mean, you can basically do anything. So, back to this equation. We can use this idea to find out what x is. And 1 plus x equals 5. So our goal is to get x by itself, and that will tell us what x is. So we got to get rid of this annoying little 1 over here. And one way to do that is we can just subtract 1 from both sides. Minus 1 minus 1. 1 minus 1 is 0. 0 plus x equals 5 minus 1 is 4. 0 plus x is just x, so write x equals 4, not x. There we go. So yeah, that's our answer, and we found x. X equals 4. If you want to test your answer, plug it back into the equation. 1 plus, instead of x, we can write 4, because x equals 4 equals 5. So 1 plus 4 is 5. So 5 equals 5, and that means we got the right answer. So yeah, that's basically how algebra works. It's pretty important stuff. So yeah, now we're gonna extend the algebra concept to equations and inequalities. So instead of having the equal sign, sometimes you'll have an inequality sign or something like that. So let's, what was it? 1 plus x equals 5. sometimes you'll have 1 plus x is less than 5, or greater than 5, or something like that. So the good thing is you'll solve this the same way. Subtract 1 from both sides, you'll get x is less than 4. So basically what that's saying, you got a number line. 4 is right here, 3, 2, and it keeps on going. X is less than that. So x is all these numbers over here. X can be 2, x can be 3, and all these numbers will satisfy this equation. If you plug in 3, it'll be 3 is less than 4. Yes, that's true. You can plug in any number except for 4. You can plug in 3.9999. That's still going to be less than 4. So yeah, that's how you solve inequalities. There's some other nuances with this, but I'll leave that for later. To give another example, sometimes you got 1 plus x is less than or equal to 5 instead of just less than. So the difference with this, when you solve it, you'll get x is less than or equal to 4. If you're showing it on a number line and you got the 4 right there, instead of doing a hollow circle like I did up here, you'll do a filled in circle. And then you can just draw an arrow over, and this represents that x can equal 4 as well. So if you plug in an x for 4, 4 is less than or equal to 4. Yes, that's true, because 4 is equal to 4. So the difference is the equals part. So yeah, that's how you solve equations with inequalities. I guess I'll get into one last thing. Let's do negative 1x is greater than 5. So this gets into multiplication. To get rid of the negative, we can multiply both sides by negative 1 times negative 1. So the specific rule with inequalities is when you multiply by a negative, you circle this and remember to flip it. Negative 1 times 1 is 1, so we'll just have x on this side. We flip the inequality because we multiplied by a negative. Or when you divide by a negative as well, you gotta flip it. Remember that. So x is less than negative 5. So yeah, that's basically just a nuance. Remember to flip the inequality when you multiply or divide by a negative. Alright, so now we're going to talk about graphing inequalities with 2 variables. So let's do it with 2 equations. So we have y is less than or equal to x plus 2, and y is greater than negative 2x minus 2. So if you graph these, our first line starts at the y-intercept plus 2, 1, 2. And then the slope is 1. So for every x that we move over, it will go up 1. So let me just add some more ticks. So move 1 over and up 1 because the slope is 1 over, up 1. Alright, so since it's less than or equal to, we can do a solid line, just about like that. And now let's go ahead and graph the other one. Starts at negative 2, 1, 2. slope is negative 2, so we go down 2 over 1, 1, 2 over 1, 1, 2 over 1, yeah, something like that, and it's just less greater than, it's not greater than or equal to, so we do a dashed line. Alright, so now comes the part where we shade in regions. Since it's less than this one, that's this line right here, we shade everything below the line. So all of this is shaded in. And this one, it's greater than or equal to, so we shade everything above the line. So if you see here, the solution to our equation would be when the shading overlaps. So it overlaps in this area right here. So everything in this area, it goes out to infinity. That's part of our solution. So that's how you graph inequalities to help solve the problems. Alright, so now we're going to talk about solving systems of equations. So that's similar to the last one where I graphed the two inequalities. So let's say we have x plus 2 equals y, and let's say we have 2x minus 3 equals y. So there's lots of different ways you can solve this. Let's start by substitution. With substitution, we isolate this equation, and let's see. We know y equals x plus 2, so we can substitute that into here. So if we substitute, we got 2x minus 3. Instead of writing y, we'll write x plus 2 because x plus 2 equals y. And now it's just the algebra equation to solve for x. Plus 3 to both sides. We got 2x equals x plus 5. Then we can subtract x from both sides. We got x equals 5. Okay, so now we gotta solve for y. So we know what x equals now, so we can substitute that in here and solve for y. So instead of x plus 2, we can write 5 plus 2 equals y. So y equals 7. So that's how you can solve systems of equations and linear equations, and like you can apply that to a bunch of different stuff like inequalities and stuff like that. Alright, so in this section we are going to talk about adding, subtracting, multiplying, dividing polynomials, and we're going to talk about exponents as well. So I'll start with exponents. Let's say we have 3 to the third. So basically what this is saying is you got 3 times 3 times 3. You got it 3 times. So that's how exponents work. So it's 27 if you multiply it all out. 4 squared, that's just 4 times 4, 16. So that's how exponents work. It's pretty straightforward. A lot of memorization is good for this. But you can also have 4 to the 0. So how does that work? So basically how this works is 4 to the 0 equals 1, and I don't know why, but that's just how it works, so you better remember that. 3 to the 0 also equals 1. If you take anything to the power of 0, it's going to equal 1. Even x to the 0 equals 1. So yeah, just keep that in mind. And you can also have negative exponents, so this is interesting. If you have 3 to the negative 1, that's the same thing as 1 over 3. How about 3 to the negative 3? That is 1 over 3 cubed, so 1 over 27. So yeah, basically when it's negative, it means you just flip it over like this, because you can rewrite 3 as 3 over 1, so flip it over 1 over 3. You can also have 1 over 3 to the negative 3. In this case, the answer would be 3 cubed over 1, because you just flip it when it's negative, and so the answer is 27. So that's how negative exponents work, and you can also use exponents for scientific notation. So this is what the big scientists like to do. So let's say you have, actually it would be 1.012, scientific notation is times 10 to the third, or 10 to the something. In this case it's 10 to the third. So how you would read this is 1, and then you just move the decimal over 3 places. 0, 1, 2, because it's over 1, 2, 3, boom. So, scientific notation can be useful for writing big numbers, because you could have something like 1.0012 times 10 to the 24th, and boom, that saves you from writing 24 zeros, so that's nice. No one wants to do that. Because, yeah, basically you just have to move this over 24 places to write that. And the next thing we're going to talk about is actually pretty big. It's polynomials. Polynomial is just like x plus 2. It's something that has 2 terms, usually a variable. It can also be x squared plus x plus 3, something like that. So let's talk about adding polynomials. If you add these two together, you add like terms. Just remember that a like term would just be the x. Let me rub this off so it doesn't get stained. But yeah, anyways, a like term would be the x's. Basically anything with the same exponents. These both have an exponent of 1. This has an exponent of 2, so you can't add those together. And you can add whole numbers together, 2 and 3. So the answer would be x squared plus the 2 x's combined to make 2x plus 5, because 2 plus 3. So that's how that works. So let's try subtracting x squared plus x plus 3 minus x squared minus 1. So we're subtracting these two things. So once again, you subtract like terms. X squared, these are like terms, so x squared minus x. Let's start by distributing this negative right here actually. So x squared plus x plus 3, the negative goes to x squared, and then the negative goes here too. 2 negatives make a positive, so that's going to be plus 1. Alright, so these are like terms, and these are like terms. So the answer would be x squared minus x, so that's going to be 0. And x is only x, so we'll just still have the x, and then 3 plus 1, so plus 4. So the answer is x plus 4. So that's how you subtract, and now we're going to do multiplying. Let's do x plus 2 times x plus 1. So this is where it gets tricky, and it really messes a lot of people up. So you just gotta remember, when you're multiplying, you start with this, you multiply it by both of these. Boom, boom. Let's start with x times x. X times x is x squared plus x times 1, x times 1. Okay, we're done with this one. Now you go to this one, and you multiply it by both of these. 2 times x. That's going to be 2x. 2 times 1, that's going to be 2. So that's how you multiply. So we're going to have x squared plus plus x plus 2x plus 2. So we can combine these two like terms. Those are the only two. So x squared plus 3x plus 2. And that's the answer to this equation. Yeah, and then we're going to talk about dividing. So when you're dividing, let's say you have x squared plus 2x plus 1 divided by x plus 1. Alright, so you want to multiply this by something that will make you be able to cancel out this x squared. So let's multiply it by x. So let's just put x right there. X times x plus 1, x squared plus 1. Then you subtract that. So x squared minus x squared is 0. And then this would be subtracted as well. So that's 1x. So that would be x plus 1. So x plus 1 goes into x plus 1 one time. So yeah, you're just going to have x plus 1 again. That's going to be 0. So basically what this is saying, this divided by that equals x plus 1. Alright, so now we're going to talk about factoring. We got the greatest common factor. So let's say we have two numbers, 6 and 9. What is the greatest common factor between these two? How do we know we break these up? So let's do 6, break it up as 2 times 3. 9, we can break that up as 3 times 3. But 2 and 3 are prime numbers, so we can't break those up anymore. Greatest common factor is the biggest number in between these, so it's 3. So that's how the greatest common factor works. And let's also talk about perfect square trinomials. So this goes back to the polynomial thing. A trinomial is a specific type of polynomial, one with 3 terms. So let's say we have x squared plus 2x plus 1. So this is actually a perfect square trinomial because we can factor this out into two things. Two binomials. Write it like that. And we're going to have plus something, since this is plus 1. And whatever we put here has to add up to equals 2. So 1 plus 1 equals 2, so we just write it as that. So if you multiply this out, you'll get this. So that's why this is a perfect square trinomial. And you gotta keep your eye out for those because they'll come up. And there's also something called the difference of two squares. So we have x squared minus 4. X squared is a square and 4 is the square root of 2. 4 is 2 squared. So these are 2 squares and it's a difference of 2 squares. So when you have this, you can factor that out into two binomials. You take the square root of that and the square root of that. So that's x and that's 2. So you do plus 2 and minus 2. And if you multiply this out, you'll get x squared minus 4. And it gets even more complicated. So there's an equation for the difference of two cubes. Let me look it up. That equation is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. And So let's say we have x cubed minus 27. 27 is 3 cubed, so a equals x, b equals 3, because 3 is, you cube 3, you get 27, cube x, you get x cubed. So we just plug this stuff into here. X minus 3 times x squared plus 3x plus 9, or 3 squared, and that's our factored form of x cubed minus 27. So that's the difference of 2 cubes. You also have the sum of 2 cubes, x cubed plus 27, and you got a different equation for that. It's pretty similar though. The equation is a plus b times a squared minus a b plus b squared. So yeah, I mean, this is the same process. Let's say we have x cubed plus 27 cubed, no, not cubed, plus 27. This would be the same thing, except instead of the difference of cubes, it would be the sum of cubes. So if we plug in x for a, x plus 3 times x squared plus 3x plus, what would be, 3 squared, so that's 9. And this would be minus, not plus. So yeah, this would be the factored version of that. And it's pretty close, but a few differences and the pluses and minuses stuff. So just remember about those two equations, difference of cubes and sum of cubes. Sum of cubes. It can save you a lot of headache when trying to factor stuff. Yeah, so basically there's lots of different ways you can factor. It takes lots of practice. Let's say you have x squared plus 5x plus 6. So what you got to look at first, this number. You're going to have x and x. If you're factoring into two binomials, you look at this sign. If it's a plus, then that means both of these are going to be a plus. Or both of them are going to be a minus. If both of these are a plus, then both of these are going to be plus. If this is a plus and this is a minus, then that means both of these are going to be a minus. So keep that in mind, it's very important. And then you look at this number next. This is going to be these two numbers multiplied, whatever you put there. So let's take this. How can you factor this out? You can do 2, 3, 1, 6. Okay, so both of those works. How do we know which one to do? How do you do that? You look at the middle number. Whatever these two numbers are, they have to add up to equal this. 2 plus 3 equals 5, 1 plus 6 equals 7, so we're going to use 2 and 3. So the factored out version is x plus 2 times x plus 3. And if you want to check your work, just multiply them together. X squared plus 3x plus 2x plus 6. So that's x squared plus, you combine these together, 5x plus 6. So yeah, it looks like we got the right answer in this case. So those are some strategies that you can use when factoring, but it does take a lot of practice. One thing that factoring can be useful for is if they give you this equation and they want you to find like the zeros of the graph, like when does the line cross 0 there and there, then you can use factoring to help you find that without graphing on the calculator. So basically, we factored it out, x plus 2 times x plus 3. And to find the zeros, we just set it equal to 0. And we got to figure out what numbers can we plug in for x to make this equation true. And since we have this as two binomials multiplied together, we can look at this individually. We can take x plus 2 equals 0, and we can take x plus 3 equals 0, and then we can solve for each one. Subtract 2 from both sides, we get x equals -2, x equals -3. So that is going to be how we can use factoring to find the zeros. So basically that's going to be saying it's going to cross 0 at -2 and -3. And yeah, I don't know, it probably looks something like that. So yeah, that's a good application of factoring. And next we are going to talk about rational expressions and equations. So let's say we have x plus 3 over 4 plus x minus 3 over 3 equals 5. So if you remember with addition of fractions, these are two ugly looking fractions. You can add them together if they have the same denominator. So these have different denominators. So what we're going to have to do is multiply both of them by something to get the same denominator. And we got to figure out what number can we multiply these two to get the same denominator. I know 12 can be factored out into 4 and 3. 12 equals 4 times 3. So I'm going to make the common denominator 12. So if we multiply this by 3 over 3, which we can do since 3 over 3 is just 1, and when you multiply by 1 it doesn't change anything. We can multiply this by 4 over 4, which is 1 as well. We will get 3 times x plus 3 over 12 plus 4 times x minus 3 over 12 equals 5. And now we can go ahead and add these together over this same denominator. So we'll get 3 times x plus 3 plus 4 times x minus 3 over 12 equals 5. We can distribute into parentheses 3 times x plus 9 plus 4 times x minus 12 over 12 equals 5. Multiply both sides by 12. This canceled out. And we can add these. We get 7x minus 12 is 3. 7x minus 3 equals 60. And so my plus 3 on both sides, 7x equals 63. Divided by 7, we get x equals 9. So yeah, that is how you're going to deal with simplifying rational equations. Just get the common denominator. You got to do some adding, multiplication, sometimes division. So yeah, that's how you simplify complex fractions and solve rational equations. Yep. So another thing we're going to talk about is similar triangles. So let's say we have big triangle right there, and actually we'll make that little triangle, and this will be a big triangle. And I don't like these at all, so let me start over. Little triangle and big triangle. So let's say we don't know how long the side is. It's x long. That's 2. That's 1. This is 6. That's 3. And this is 9. The question is, how long is this side? And you can solve that if I tell you that these two triangles are similar triangles. By that I mean all the angles are the same. This is the same angle as that. This is the same angle as this. They're all the same. So if they're all the same, what we can use is I forgot what it's called, but we can do x over 9. We take this side on this one and this side on this one, and we put x over 9. And that is actually equal to, we can take this side and this side, 1 over 3. So we put 1 on the top because we put x on top. So these are both from the same triangle, so we put them both on the top. 3 and 9 are on the same triangle, so they're both on the bottom. And the main point is you just have to be consistent. They either have to both be on the top or both be on the bottom. And then once we got this equation, we can actually cross multiply. So that's going to give us 3x equals 9 divided by 3. X equals 3. Oh, and that is going to be your answer. So this side is 3 units long. So that's how you're going to use proportions and similar triangles. Alright, so now we're going to talk about roots and radicals. So first, let's talk about square roots. Square roots are an interesting thing. So let's talk about this briefly before, but let's say we have the square root of 9. What is the square root of 9? So with this, what you got to do is you got to break it up. You can break up 9 into 3 times 3. If you can break up the square root into 2 identical numbers, the answer is just going to be that number. So the answer is 3. But wait, it's more complicated than that. If you have the square root of 18, how can you break up 18? You can break it up into 2 times 9. These are not the same numbers, so what you do, you can continue to break this up into 2 times 3 times 3. So we got 2 of the same numbers, but 1 that's not. So what you do in this case is you can take 3 out. You're left with 3 square root of 2. That's the answer right there. So yeah, that's pretty straightforward, and that's how you deal with square roots and simplifying radical expressions. This is another word for radical. You can also have cube roots. Let's say you have the cube root of 54. That's a big one. So, I mean, if you don't know where to start, you can always start with 2. Take a 2 out. 2 times 27. What else can we take out? We can take out a 3 because 2 plus 7 is 9, and 9 is a multiple of 3. So 2 times 3 times 9. Okay, so now we can break up the 9. 2 times 3 times 3 times 3. Alright, so we got 3 3s. So the difference between a cube root and a square root is, with square root you just need 2. With a cube root you need 3 identical numbers, so the cube root of 54 is 2, sorry, not 2, it's 3 cube root 2. So yeah, that's how you handle cube roots, or, I mean, if it's the root to the 4th, it's the same, you just need 4 identical numbers instead of 3. And, yeah, so that's basically how you do that. So, let's say we have 2 square root 3 plus 3 square root 3. How do you solve that? Basically, it's the same thing as 2x plus 3x, except instead of x you got square root 3, so the answer here is 5x, the answer here is 5 square root 3. So it's pretty straightforward, just think of the square root as an x. And remember, you cannot do 2 square root 5 plus 3 square root 3, because these are different terms. They have to be exactly the same, like up here. And I think that's basically it. You'll follow all the other same rules. Just remember, if you're gonna work with these, you just gotta make sure they're the same. And sometimes you gotta simplify them like I did up here before you can add in, subtract, and stuff like that. Oh, another thing, you can also rewrite the square root of 2 as 2 to the 1 half. 2 to the 1 half equals the square root of 2. 2 to the 1/3 equals the cube root of 2. So yeah, just if you have rational exponent, it represents a radical, so just keep that in mind. You can also have 2 to the 2/3, so that would equal the cube root of 2 squared, since you got squared there. So yeah, that's how that works. And the last thing we're going to cover is the quadratic equation. And yeah, people don't like this one. It's kind of annoying. So the equation is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2 times a. So yeah, you would probably want to memorize that. It's pretty useful if you don't have a calculator. So basically what this helps you do is to factor functions. So let's say if you have a polynomial like 3x squared plus 4x plus 1, and you're trying to factor this out into 2 binomials, x plus something times 3x plus something, and you're like trying a bunch of numbers, you really just can't get it like 1 and 3, yeah, that doesn't multiply 2 equal 1, so that doesn't work. If you can't figure it out, then you can always go to the binomial equation. It's pretty useful if you understand how to use it. So basically what you know how to substitute in for. First term, 3 represents A, second term, 4 represents B, third term, 1 represents C. So if you plug this into the equation, you got negative 4 plus or minus the square root of 4 squared minus 4 times 3 times 1 over 2 times 3. And so let's simplify this some more. Negative 4 plus or minus the square root of 16 minus 12 over 6. Negative 4 plus or minus the square root of 4 over 6 equals negative 4 plus or minus 2 over 6. So that means we got negative 4 plus 2 over 6 and negative 4 minus 2 over 6. And these are both answers to our equation. Negative 4 plus 2, negative 2 over 6, negative 6 over 6. So, we got negative 1/3 and negative 1. So these are both zeros, and it would have been really hard to figure out that on our own. So basically, negative 1/3 goes here, and negative 1 goes here, and those are the answers to our equation. So yeah, that's it. Thanks for following along.